Hello guys, welcome you all for this end-to-end session of AML. I will not say it is AML. AI, ML, DL, computer vision, INLP, and then LLM, everything, right? So in order to become a successful data scientist, okay, that's what the major goal of us, okay? So hope you guys are enjoying. We are enjoying a lot and we are learning a lot each and every day. So guys, today you guys gonna be amazed with whatever things that we are gonna give it to you, okay? Only like I think the logically it's gonna be only 5 lines of code that we're gonna have for this reinforcement learning concept that we are studying for the past 10 days, right? So yeah guys, so before coming to this session, as always, please make sure that you guys watched all the previous session videos so that you can have a better understanding of what we are talking. Okay. So and one more thing, guys, please make sure that you guys subscribe to our channel because like every day we are just posting a new video so that we will be not missing any of our videos. Okay. And one more thing, we are having in our channel 2000 plus quizzes. Just go and attend it. It can be right or wrong. Okay. We are not God, right? We cannot be right all the times. Okay. Just go and attend it and let us see how many of them getting right and wrong. And you just learn from the wrongs and start to explore more on the rights. Okay. Like that. Okay. So yeah, without wasting any time, let us jump into today's session. Today's session is a coding part of reinforcement learning, guys. Okay. So actually it's gonna be a last session for our machine learning. Okay. Hope I think it's like nearly like 50 plus sessions, 60 plus sessions, okay, for this machine learning, okay, where we have covered all the concept of supervised learning, all the concept of unsupervised learning. Now we are covering reinforcement learning. Along with we have covered association rules also. Okay, so we have covered everything, both the theory concept, black box, and coding. Today we're gonna conclude this machine learning part, guys. Not we're gonna conclude the entire thing. Okay, only machine learning part. Okay, so yeah, without wasting any time, let us jump into today's session of coding part of reinforcement learning. Okay, guys, just come with me. Okay, I'm gonna explain in a very simple manner. Okay, you're gonna build a magic from it. Okay, you can. Okay, let us understand bit by bit. Okay, let us understand the problem statement first, what this coding is all about. The problem statement is moving a line to reach the goal. That is what our problem statement. Imagine you are on a line with 5 position numbered from 0 to 4. 4 is the goal. Okay, consider, guys, it is a simple gamified code. Okay, just try to understand. That's it. Okay, you are on a line. Okay, you are standing on a line where you're gonna have 5 different positions. It is named as 0, 1, 2, 3, and 4. If you reach 4, 4 is your goal. That's it. Simple problems. Hope you guys are able to understand, right? Let us move on to the coding, guys. Just see here. That's it. This is what the coding. Okay, let's go one by one. First of all, I'm just importing the necessary library, that is import numpy as np. So it's a numerical library which is used to perform all kind of mathematical operation. First thing, I'm going to define 5 position. So how I'm defining means from np, that is numpy, I'm just creating zeros, 5 zeros. Okay, 0 0 0, like that. I'm just creating 5 zeros for my position. That is called as q table. I'm just updating the values to the q table. Initially the q table is going to have 5 zeros. That's it. Okay, so before training, how my q table will be 5 zeros. Okay, here I'm just specifying some parameters. Okay, this is learning rate, this is gamma, this is imspan. Guys, just forget everything. These three are like learning parameters. Okay, that's just a parameter, hyperparameter. Consider it is 1, 2, 3. I'm just assigning some random values from 0 to 1.0. So like a floating value, like 0 0.1, 0 0.9, 1.0. Randomly, I'm just randomly assigning. Okay, now let us move on. I'm just printing a new line and a q table during training. Before training I have printed, so during training also I'm going to print that. I'm going to train, that is I'm going to go for a trial of 10. Okay, 10 trials I'm going to do. That is what this for loop says. For a range of 10, I'm going to have a 10 different trials. First, I'm in this 0th position, right? Guys, whenever we start, we're going to be in the first position, right? That is what the position is 0. Yeah, let us come to the loop. While the position is less than 4, that means if you are not to the final stage, the goal, what do you need to do? You need to move one step forward. Okay, and you need to update your hyperparameters, right? We are having epsilon, we are having gamma, we are having learning rate, right? We need to update everything. Okay, we need to move one step up, like one step to the right. Sorry, I have not. So one step to the right. You are on the 0th position. You need to move one step to the right. Okay, that is what this one. If the random value is less than epsilon, else you need to get the maximum value that is present in the table itself. That's it. Okay, that is what this line, guys. Simple. What this line say? Whenever you are not to the goal, you need to move one step to the right based on this condition. That is, a random value should be less than epsilon value that we have given, and also, or we need to take the maximum value from the table itself. Okay, now what is our next step? What is our next position? Already position plus the move. That's it. Consider we are having in the position of 0 first time. Now our position is 1. 0 plus 1 is 1. That's it. Now our new position is 0. Simple, right? We have started from 0. 0 plus 1. Now it's 1. Okay, guys. Here we have started at 0, right? Consider our position move is 1. Now our next position will be 0 plus 1, that is 1. We are from 0. Now we move on to the 1. Now what is our reward? Reward gonna be 1 if the position is 4. Otherwise it is 0, because our goal is 4, right? Now tell me, right, where we are in 1, whether we're gonna get a reward or not. We're gonna get 0, right? So that's the thing, we're gonna get a 0 unless and until we reach 4. We're gonna get only 0. Okay, now moving on, we need to update this q table, right? We have initialized it to only zeros. Now I'm gonna update this q table with this position. That is simple mathematics, guys. Just plus and minus, just remember like that. Okay, learning rate into reward plus gamma value, q table's value at that position minus q table value of the current position. Okay, it's the next position, current position, guys. This is a q formula. Okay, q learning formula. I hope like it's a Bellman equation. This thing we have discussed, I think, in the second session of reinforcement learning. Please make sure, if you guys doesn't understand, please make sure go there and then just understand it. Okay, so this is just a formula. Consider we are just updating this q table that we have initialized to 0. That's it. Okay, now our position is the next position. That's it, because 0 to 1. Now the position is 1, and we are just printing the q table because we are updated it here, right? And we are just multiplying a random value to this epsilon because we have initialized to 1, right? We are just having something like a multiple of 0.995. It's a random value, guys. That's it. Okay, this is what the flow, guys. Okay, that's it. Okay, I'm just printing a new line, and then I'm just printing after training. What is the thing after 10 epoch? Okay, after 10 kind of training. Okay, 10 episode. I'm just explaining in a simple English term. Let's see. Okay, we are having a problem statement where we're gonna have a 5 position, right? So reaching a 5th position is our goal. 0, 1, 2, 3, 4. That's it. 4th, if you reach 4, that is your goal. Okay, there are going to be some hyperparameter, right? So whenever you play a game, there are going to be some kind of obstacle, there are going to be some rewards. That is what a hyperparameter. Okay, consider you are in the first position, that is 0. Okay, you need to move to the first position. Okay, then unless and until you reach 4, you doesn't not gonna get the reward. That's it. This is what this while loop is doing. Unless and until you get nearer to 4, you're gonna loop it through, and then you're gonna update the q table. That's it. Okay, let's see the output. Just see the output, guys. Just see the output. Okay, before training, everything is 0, right, guys? This is what I have explained, right? Before training, everything is 0. Now we have trained for 10 epoch, right? This is what the 10 epoch. Initially everything is 0, but see here, the third position is 0.1. What's the reason, guys? Because our end goal is 4, right? So from the point of view of calculation, like 0, 1, 2, 3, 4. 4 means 5th position. Okay, that is what our goal. So the position which is closer to our goal get the higher reward. So from this you can see 0.1. Third position gets more reward. Similarly here you see, now here the third position gets more reward. Third position gets more reward. So from this it is clear that as close as you get to the goal, you're gonna get more rewards. Okay, when you reach the 10th step, you guys see here you are getting nearly 65%, that is 0.65. So before that you are having 0.23, before that you are having 0.05, and then before the first, that is your starting position, you are getting 0.009. Guys, I hope like it's completely scratch method, guys. Okay, this is how a game is built. Okay, Finally, this is what the final thing, right? The final 10th epoch. Okay, this is what the final thing that we are getting. Okay, I hope like this is never gonna be taught in any of YouTube channel or any of their guys. Okay, I hope like we are very happy like we are able to do this to you guys. Okay, so yeah, uh, let's have a English words of what they are doing. Okay, the Q table value indicates that as you close gets to the goal, that is a position 4, the value increases, shows that the program has learned to perform moving towards a goal. The higher value at the position 3 means it's beneficially to be there as it is closer to the goal. Simple, okay? Because the third position is very closer to the goal, so it is higher reward. Okay, guys, simple, right? There is no rocket science here. Okay, simple. Only 5 lines of code we have implemented reinforcement learning. Okay, let's just break down this step. So we have imagined that we are having 5 position numbered from 0 to 4 in a line. We have started from a position of 0 and we want to reach 4. That is our goal. In each step, we move one step to a right. If we reach 4, we get a reward. The program learns how to move to reach the goal faster each time. Okay, that's it, guys. Okay, this is what the base thing. uh, I will say it's a black box behind the reinforcement learning, guys. Every algorithm of reinforcement learning built built in this manner only. Okay, they're gonna have a table, they're gonna create a scenario, create an environment, and sorry, we're gonna have training on it. That's it. Here, what is an environment? A line is an environment. Okay, and the position 4, that is our goal. Okay, 0 to 4 is our goal. Okay, and who is the agent? Ourselves is the agent, right? We are just playing with it and we are just getting the result done. Okay, hope I have explained you in a very simple manner, guys. Hope you guys have enjoyed. Okay, when I created this, I have enjoyed a lot, guys. Okay, still now, if you guys are feeling any difficulty, anything that you guys doesn't understand, please ping in the comment section. We are here to help you. We will take up and we will solve your doubts. Okay, so yeah, sir, over to you.
Okay, so reinforcement learning, guys. So let us uh, understand this particular application. So absorb the information, digest, and now let us apply the information concepts, whatever we have learned. Okay, so mimic this and do imitation exactly what we are teaching so that you can build this project. Okay, so first of all, the problem statement is moving on a line to reach the goal. That is the problem statement, very specific in single line. Okay, very clear. Okay, um, imagine you are on a line with 5 position number 0 to 4. That is the goal. Okay, so then we'll import the necessary, okay, libraries. We have got import the numpy as np, and then we take q table equal to np dot 0, which is 5 positions on a line. Okay, we'll print the q table value before training and print the q table, and then we have all these we have these dimensions. Okay, so then we will print the print q table value during the training, and for in range around 10, training the 10 times. So that means we have to train the particular this for 10, and there are pros like position like start or at a position 0. So that is POS is for the position, while POS 4 moving until reaches position 4 goal. That is again a goal. Then move. We have to define each and every step, guys. So random or best move. Okay. Then we have next position, which is right by one step. Reward equal to 1 if next position is equal to 4, else 0. We have to define it. Okay, so this when we are defining these particular things, so these particular syntax na, so what happens that it will behave accordingly. We are defining the goal. Reward if reaches the goal, else, okay, and then we have Q table position plus equal to IR reward plus gamma. Okay, Q table next position, Q table POS again position equal to next position. So you can define it according to you, like whatever objective function you have, so you can do it in your project. So again, print Q table, but fundamental structure should be same. Inside can be anything, like you can, as per your objective function. So this is which we have to define. Okay, we have to define the APS again. It is reducing randomness over time. So print n, okay, again displays the learned q value. Print q table, okay, value after training, then print q table. So once we define all these syntaxes, we get the syntax, and then we get this outcome as per whatever we have defined. So you have the output of this particular model as per whatever we have defined. Okay, so you need to be very, very clear into each element, whatever is there when you are defining. Okay, so do we have anything else, Raja, to discuss?
No, sir, nothing. So this is what the simple coding that we are having. That's it, sir. Yeah.
Okay.
Yeah, guys. Hope we have made a justification for this reinforcement learning, right? So yeah, guys, like this we have built overnight. Okay, as sir has mentioned, we need to just have a logic, guys. That's it. Okay, we just need to follow a logic, and we can build anything on top of it. Okay, for us, our environment is a line, 5 position. Whatever things that you can build on top of it, your environment can be circle, your environment can be rectangle, and you can have multiple points, anything. But the logic is going to be very same. Okay, you need to fix your goal, you need to go for the move, and you need to update your queue table, and you need to create a randomness, and you need to make your agent to learn. That's it. Okay, so hope you guys have enjoyed the session, guys. We have enjoyed a lot when we build, right? We have enjoyed a lot. Okay, that's the same thing from you guys. So guys, one more thing, we have completed reinforcement learning. Not only reinforcement learning, we have completed machine learning, guys. Okay, we have completed playing with data, we have completed entire thing related to machine learning. Okay, from the next session we are moving on to a new topic called as deep learning, guys. Okay, come with most excitement. I'm very excited because like every day, every concept, after every concept we're gonna have a coding session like this. Okay, so hope you guys are gonna enjoy. Okay, so we're gonna step into the new concept called as deep learning. Today we are completing a machine learning, guys. Everything, supervised, unsupervised, reinforcement learning, association rule, everything. Okay, so yeah, guys, hope you have enjoyed. Okay, we have done nearly 100 plus session, guys. Okay, so I have learned a lot. Sir would have learned very lot. You guys gonna be a same thing. Okay, so yeah, thank you, guys. Thank you so much for all your time. We will until next session. Bye, guys. Take care. We will all meet in the next session. Bye, guys.